Good day and welcome back for the final part of our discussion on differentiating exponential functions. And as I mentioned at the end of our previous video, you can find an associated worksheet located in Canvas on differentiating exponential functions. And if you have not done so already, I would recommend that you give yourself 20 to 30 minutes and work through as many of these examples as you can. And I'd also like to note again that by design, the worksheet actually contains more problems than I think we could reasonably complete in, say, 20 or even 30 minutes. And I do that on purpose so that you have additional extra practice problems to work on. And you will also have probably noticed that I have full solutions posted on Canvas so that you can check your work versus those solutions and also see how I present my work for these problems. I wanted to, in this video, go over problems 3a and 4b. But note, 3a and 3b both have the same generic form. And let me remind you of something we've already discussed. If you want to differentiate a function of this form e raised to the f of x, we use the chain rule. We differentiate the outside function, evaluate at the inside function, and multiply by the derivative of the inside function. So if that inside function, 3x cubed, as it is in 3a, we would have the derivative of the outside function evaluated at the inside function multiplied by the derivative of the inside function. And one more step and we're done. We have this e to the 3x cubed, and using the power rule, the 3 comes down, so 3 times 3 is 9. The new power is 1 less than previously. In terms of problem 4b, we have an indefinite integral to evaluate. Now, remember our process. We can either directly or through some algebraic manipulation compare to our common formulas, or we use the substitution. And we've seen up to this point many examples of substitutions, but this is an example where we want to use some algebraic manipulation. We simply want to FOIL or expand out the square. So doing the algebra, we would have e to the x plus e to the minus x times e to the x plus e to the minus x. And if we just write out these terms one by one, we would have e to the x squared plus e to the x times e to the minus x plus e to the minus x times e to the x plus e to the minus x quantity squared. And this just gives us some really good reminders. E to the x quantity squared is e to the 2x. E to the x times e to the minus x is equal to 1. And just to note, so there's no confusion with this, e to the x times e to the minus x, we can rewrite e to the minus x as 1 over e to the x to get back that 1. So the 1 plus 1 gives us a 2, and then e to the minus x quantity squared is e to the minus 2x. And of the 3 functions making up the integrand, 2 of them have the same form. And we've seen previously that if we want to anti-differentiate e to the kx, this is 1 over k e to the kx. So making use of this formula, we would have term by term, 1/2 e to the 2x plus 2x minus 1 over 2 e to the minus 2x. And because it is an indefinite integral, we needed plus c. So this finishes up our discussion on differentiating the exponential functions. In our next video, we will move on and begin differentiating the logarithmic functions. So stay tuned and take care.